Okay, so far we have developed three Garch model using three distribution. Okay, now question is that out of three model, which one is the best? Okay. Okay. So first, suppose we develop the model having distribution is normal, right? First, we check one by one. Because we have developed three, we check one by one which one is the best. So first I start with the normal Gaussian distribution. Other thing remain unchanged. You can see Arch1, Garch1, meaning that this model is Garch 1 model. So, and I estimate this model, and this is the outcome, right? Normal distribution, right? Okay, now the question is that when the model will be good, will be best. A model will be best, a Garch model will be best when there is no serial correlation, residuals are normally distributed, and when there is no arch effect, arch, ARCH effect. When these three things will be present, then the model is the best. Okay, first I check with this one, with this model, when the distribution is normal. Okay, first I check whether there is serial correlation or not. How to check? I go to view, then I go to residual diagnostic, then I come here, squared residuals. We shall be doing squared residuals, this one, and suppose we choose 36 lakhs, we choose, okay. So here is the Q statistics, you can see, right? Q statistics 36 lakhs and corresponding p-value. Okay, and it is the correlogram of residual squared under Q statistics. What is the null hypothesis? The null hypothesis is there is no serial correlation. That is the null hypothesis. And we can reject null hypothesis when the p-value is less than 5%. Only then we can reject null hypothesis. But here, what is our p-value? You can see all p-value are more than 5%, right? You can see from here. What about this one? 83.1%. This one 42.4% p-value. What about the last one? 64.8% the p-value. So all are more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? There is no serial correlation. So we cannot reject it, meaning that the Garch model with normal distribution has no serial correlation. So that is a good sign. Okay, then we check whether this Garch model has arch effect or not. Okay, how to check arch effect? I go to view, I go to residual diagnostic and I choose the arch, right? I choose it and it is the arch, right, already given, and I choose OK. Okay, it is the arch test, right? Arch test, test of heteroscedasticity, observed R square and corresponding p-value. How much is the p-value? 83.24%, meaning that more than 5%. What is the guideline? The guideline is that if the p-value is more than 5%, we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no arch effect. So here we cannot reject null hypothesis, meaning that we accept null hypothesis. And what is our null hypothesis? There is no arch effect. So this model, this Garch 1-1 model with normal distribution has no arch effect. So that one is a good sign. That means the residual do not have any arch effect. So that is a good sign. Okay, the third assumption is residual must be normally distributed. That is desirable. So I check, I go to view, I go to residual diagnostic, then histogram normality test, right? I choose here. Okay. So here we shall be checking the cabarrus statistics and corresponding p-value. What is the p-value? Less than 5%, right? So we can reject null hypothesis. Okay, here what are the hypotheses? What is the null hypothesis? Residuals are normally distributed. And what is alternative hypothesis? Residuals are not normal. And what is the desirable? The desirable is that residual should be normal. That is the desirable to become a good best model. Okay, here we can reject null hypothesis because the p-value is less than 5%. So we can reject null hypothesis, meaning that we accept alternative hypothesis. And what is our alternative hypothesis? Residual are not normal. So from this point of view, this model is not good because residuals are not normal. So what is the decision of this Garch 1-1 normal distribution model? The decision of this model is there is no serial correlation, there is no arch effect, but so those are good sign. But there is one bad sign is residuals are not normally distributed. Okay, so this is the result for this model. Now we check the second type of error distribution, which is student t distribution, and we see about that model. Okay, I go to estimate, then this one I already checked. Now I check the student T fixed degree of freedom, this error distribution I check now, right? Okay, and other thing remain unchanged, other thing all are remain unchanged. Then I press OK. So this is the outcome, student to distributions, and I check whether all the assumptions are fulfilled or not. Okay, first I check whether this model has serial correlation or not. I go to view, I go to residual diagnostic as before. I'm following the same thing that I did before. I choose this one, correlogram, and 36 lakhs, right? As before the Q statistics here, right? You can see Q statistics and corresponding p value, right? And you can see the p value all are more than 5%, meaning that we cannot reject null hypothesis. What is our null? There is no serial correlations. So this one is a good sign for this model. Okay, then I check whether this model has a arch effect or not. Arch effect, as before, I go to view, residual diagnostic, then arch effect, and arch, right? It is already given. Okay, this is the arch test, observed R square, right, and corresponding p value. How much is the p value? 80.41%, meaning that more than 5%. What is the guideline? The guideline is that if the p value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. And here, what is our null hypothesis? There is no arch effect, which we cannot reject, meaning that we accept, meaning that in this model with student T distribution is not affecting by arch. So this one is a good sign for this model. Okay, we check the third one. What is the third one? Whether the residual is normally distributed or not. As before, I go to residual diagnostic and I check the histogram, and you can see the cabarrus statistics and corresponding p value, right? The p value is less than 5%, meaning that we can reject null hypothesis, accept alternative. And what is our alternative? Residual is not normal. So it is the bad sign, because we have rejected the null hypothesis because the p value is less than 5%, and as a result we have accepted the alternative. What is alternative? Residual is not normal. So that is the bad sign. Okay, what is the decision of this model with student T distribution? In this model, yes, there is no serial correlation, there is no arch effect, but the residual is not normally distributed. So that is the bad sign. So this model, student T model and normal distribution model, is the same decision. What about our third model? having get. So uh, we go to estimate. Okay, this one we have done right now. The third one is the get with the fixed parameter. We check this one. Okay, we run this model. Sorry, I have done mistake. I do again. Get with fixed parameters, right? So this is my model with get, right? And we check other thing remain unchanged. I click OK. You see get general error distribution, get, right? Okay, first I check whether this model has serial correlation or not. I go to view as before, residual diagnostic, then correlogram, squared residuals, right? I click here, and 36 as before. Okay. Okay, here the Q statistics and corresponding p-value. You see all p-values of 36 lakhs are more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? Residuals have no serial correlation. So that is a good sign. Then we check the second one. There is an arch effect. So as before, I come here, arch test. Okay, arch test, observed R square and corresponding p-value 74.74%, which is more than 5%, meaning that we cannot reject null hypothesis. We accept null hypothesis. And what is our null hypothesis? There is no arch effect. So this one is a good sign. We check the third one, residual diagnostic, and we check the test of normality, and this is the Jarkabera, and corresponding probability is less than 5%, meaning that we can reject null hypothesis and accept alternative. What is alternative? Residuals are not normal. So that is not good sign. So what is the decision of this model? The decision of this model, there is no serial correlation, there is no arch effect, but the residuals are not normal. So there is no serial correlation, that is good sign. There is no arch effect, that is good sign. But when the residuals are not normal, that is a bad sign. Okay, what is the decision of the three model? Actually, three models have come to the same decision, that they do not have any serial correlation, they do not have any arch effect, but their residuals are not normal. So that is only bad sign. Other two are good. No serial correlation, no arch effect, that is good. But the problem is that residuals are not normal. That is bad sign. But the thing is that although the residuals are not normal, but still we can accept the model. Why? Because although residuals are not normal, but the estimators are still consistent. Estimators are still consistent, and many econometricians said that although the residuals are not normal, but still we can use the model for forecasting. Still we can accept this Garch model for uh, for uh, for prediction or so on, right? And so we can also use the model and so on.